Okay, so hopefully the camera or the video turns on. It's got a blue light now instead of yellow. I don't know what that means. All right, so we're going to talk about chapter 20, which is on, well, it says hypothesis test for a mean, but we already kind of know that, right? And do I dare move this? Yesterday when I moved this, I got in trouble a little bit.
We want 7 more equations.
Well, you'll get them. Okay, can I move this without disconnecting anything? There we go. Okay, so we're going to be doing chapter 20, which is called hypothesis test for a mean. Inference, yeah, same thing. Okay, now, there are going to be 2 types of tests in here, 2 types of tests. Okay, now you already know one type of test. What's the test that you know?
The z-score, we know sigma.
Okay, we know
Sample mean.
the sigma, and that leads to the z-test, which is x bar minus mu over sigma over the square root of n. Okay? Now, you still need to know that for this chapter, but we're going to throw in another option, which means you don't know sigma. Okay, now, the equation is extremely similar. Okay, this is part of the reason why people get confused, but instead of a z, we're going to be using a t. Okay, t is, do you want me to turn on another light now that this is working?
Yeah, I like that.
Let's see here. Oh, I turned them all off. I didn't even
Yeah,
do
I
that.
was like,
Is that okay?
yes, please.
Yeah.
Thank you. I mean, thank you.
Let's see if this is that better?
That's great, yeah.
We get a little bit more glare on the board, so it might be hard to see on the video, but, all right. The formula for the t-score is x bar minus mu over s over the square root of n.
That's standard deviation.
Standard deviation of the sample. Okay? Now, let's talk a little bit about the t-distribution. Okay? It was discovered by a guy named William Gossett. Okay? Now, here's the interesting thing. You know, yesterday was Pioneer Day, or as Jordan says,
Pie and beer day.
Pie and Beer Day. Now, the only reason I bring that up is because, believe it or not, William Gossett worked for a beer company. Okay? And he initially published this with a pseudonym, which was Student T. That's why we call it the t-distribution, but it was discovered by William Gossett. It is like the normal distribution with larger tails. Okay? So for example, if this is the normal distribution in red here, okay, we're going to pretend that's the normal distribution. The t-distribution also is bell-shaped, but it has larger tails, okay? And the shape changes based on what we call the degrees of freedom. Now, why we use that name, I don't know. It's kind of a weird name, but I always abbreviate it DF for degrees of freedom. Your degrees of freedom equals n minus 1. Okay. So I'm going to give you a new distribution. But yeah, so here's the main thing, okay? Chapter 17 dealt mainly with the Z distribution. I'm going to focus, I think you're going to have some Z's and some T's in chapter 20. But I'm going to focus mainly on the T because that's the new stuff. Okay? Does that make sense? All right. So let me start. We're going to go through the same 7 steps as normal. Do you want me to do this on the computer or on the board? Computer? Okay.
Can you get it to take what you're?
Yeah, I'm going to do it right now. Okay. All right, so I'm going to open up a new sheet here. Okay, so here we go. The CDC, or Centers for Disease Control, says the mean cigarettes smoked per day by smokers is 18.1. We obtained a simple random sample of 40 retired smokers to see if they smoke less, because they're less stressed out. They don't need as many cigarettes, right? Or maybe they're more stressed out because they're not making any money. I don't know. Okay. The data results in a mean of 16.8 cigarettes per day and a standard deviation of 4.7 cigarettes. Using alpha equals 0.10, find out if retired smokers smoke less.
Oh, a different alpha.
Ah, finally, we got a different alpha. It's about time, right? Okay, now, why would we use a different alpha? What do you think of my sample size? 40 isn't a very big study, is it? It's bigger than 30. And in fact, maybe I should, before I do that, before we do this problem, I should talk about some requirements here, okay? So let's talk about, maybe I'll use my blue. Where'd my blue go? Okay. Requirements. And this works for T or Z. T or Z, okay? Number 1, it must come from a simple random sample. Now, by the way, let me just mention this for your project. Technically, the only data collection method that you're doing a simple random sample is your phone book, right? Now you're doing some pseudo-random stuff like systematic. Technically, that breaks the rules, but you can treat those as a sample. Cluster definitely breaks the rules. I still want you to do it as if it was a simple random sample, but technically cluster sample or any other sample type breaks the rules, okay? Number 2, we are assuming that our samples are independent, okay? Number 3, the data are normally distributed. By the way, how do you find out if your data are normally distributed? Well, not the chart. What graph? The histogram. Okay, you need to check and make sure your data are normally distributed. Now, what happens if your data are not normally distributed?
Then you have to take proportions from within the data, right? To make
No.
it. Oh.
Then you're going to tell me, oops, my data is not normal, but I'm still going to do the test anyway. Okay, but it means
if it were normal.
Well, you'll treat it as if it were normal, but you'll say, we did this test anyway, our data are not normal, so we are subject to scrutiny. You know, our results may not be representative, okay? So you should always check that it's normally distributed with no outliers. And your n should be greater than or equal to 30, okay? That's why I want your samples to be greater than or equal to 30, okay? Now, occasionally students do get stuff that's not normally distributed. Just let me know that you're aware that it's not normal, but do the test anyway, okay? It's good practice, okay? All right, so those are the three main things. Okay, let's go back to our Excel spreadsheet here. Okay, step number 1 is, we're gonna have to hurry, we've only got 25 minutes left. Find the numbers. Okay, CDC says the mean cigarette smoked per day by smokers is 18.1. We're going to say that to mu equals 18.1, right? We obtained a simple random sample of 40 retired smokers, and equals 40. The data results in a mean of 16.8 cigarettes per day. X bar. Why is it X bar and not mu?
Because it comes from a
Sample of 40, right? 16.8 cigarettes per day and a standard deviation of 4.7.
The standard deviation within the sample is 4.7.
It was in the sample, so we call it S. It's not sigma this time. This is S. Okay. Now.
And we also know our alpha is 2.10.
There we go. 4.7. And my alpha, this time we're going to use 0.10. Okay. Is there anything else I need? Nope. Okay. If I gave you raw data, could you figure out the standard deviation yourself?
I sure hope so.
Could you do it with your calculator? Like on a quiz on Monday. If I gave you 20 numbers and I said, figure out if this data are normal, or excuse
We have
me.
to go back to the original standard deviation formula.
Well, you could do that, but that would take way too long. Do you know how to do it on your calculator?
Calculator. And split in.
Okay, so here's the deal. This is your homework for the weekend. In addition, okay, now I can tell Jordan's calculators, Jordan paid a lot of money for that calculator.
I just rented it from the library.
Oh, you rented it from the library, that's fine. Let me see your calculators. Show me, lift them up so I can see. Yours is good enough, yours is good enough, yours is good enough. You don't have one, yours is good enough. All of your calculators can do this. Now, some of you have Casio, Texas Instruments, whatever. Do you know how to find out how to do the standard deviation? Go to YouTube, say, how do I do standard deviation with model number, blah, blah, blah. And you'll watch a YouTube video that'll probably be less than 5 minutes, and they will show you how to do that, okay? I don't know how to use your calculator, unless it's exactly like my calculator.
So you're saying that, okay.
But your calculator will do standard deviation without you just punch in the numbers, okay?
So the very original formula we learned in the very first test about how to calculate standard deviation by hand.
Will take way too long to do.
Way too long. But this will do.
But you could do that, but not on a quiz. It'll take way too long. You'll spend the whole time calculating the standard deviation and won't finish. Okay? I'll only make you do that on the final again. Okay? All right, step number 2 is categorical or quantitative, and our data are quantitative, clearly quantitative, okay? Step number 3.
This is.
State the null hypothesis and the.
Null and the alternative hypothesis. And Dalton, what's the null hypothesis?
That one is 18.1.
Is that correct?
No.
No. It's only half correct.
You.
Mu. Why did you forget the mu?
Because of YouTube.
Mu equals 18.1. The alternative hypothesis is what, Sandra?
Hey, it's just the end.
18.1. Okay. Step number 4 is,
Pick a formula and calculate.
okay, find the test statistic. Okay. And the test statistic is, what's the formula? T equals x bar minus mu over s over the square root of n. Okay. Are you glad we're in the library today?
Yeah.
Sure.
Okay. So, Aaron, can you help me type in this formula?
X bar. So, 16.8
16.8.
divided by,
Nope.
minus, I'm sorry.
Minus
18.1
18.1.
divided by
Okay, we're going to press enter first. And then we're going to do
4.7
4.7 divided by
SQRT.
square root of 40. Okay. We're going to divide the numerator by the denominator, and we'll get negative 1.74. Okay.
Yeah, in this case, we cannot have two terms, like negative 1.74 or positive 1.74.
You're asking, is this a two-tailed test?
Yes, is it?
Is this a two-tailed test? Alex says no because?
Because this is the other test that you told us was for one side. Because we're trying to find everything that's less than. So we want to know.
Yeah, okay, so you're going there. Because my alternative hypothesis is a less than, it's a one-tailed test, correct? Okay. All right, so I got a value of negative 1.74, and I'm going to label that what, Jordan?
Sorry.
What do I label that? That's my t-score, as opposed to my z-score, right? Okay?
Is there a different thing in the book?
There is a different thing in the book. Yeah, there's a different table.
And does the table work the same way? Finding.
No, it does not work the same way. Okay? We'll go over that in just a minute. Step number 5 is find the p-value. Okay? Now, you're probably not going to like this table as much as you like the z table.
Yeah, this one.
Okay? So there's still 2 methods, though. You've got your chart, and you got the computer. Okay? Now, so I've got here, actually, I should probably look and see in the book where it is. I believe it's in the back of the book. Oh, why is it not in the back of the book? Is it in the front of the book?
It's on the formula sheet.
It's in the back.
It is on the formula sheet. But it's in the blue area, I think. Okay, so it's on page 699 in your book. But I have a copy here that I like better. Actually, I think it's still open here. Okay, so let's look at the chart first, because that one's going to be the harder one and the not fun one, okay? So I've got your, this is what it looks like, student T probabilities. This looks just like the one on page 699, okay? Now in column C here, I've got your degrees of freedom. I told you the degrees of freedom are, in this case, in fact, maybe we can go back to here.
What is it?
Degrees of freedom equals
Oh,
It's n minus 1.
n minus 1. So 40 minus 1 is going to be 39, right? Okay, you can add that to your list of numbers if you want, but you don't always, you only need degrees of freedom on the t-test. You'll need it on the chi-square test, but that's going to be a completely different formula, okay? But for the t-test, it's n minus 1. So I've got 39 degrees of freedom, okay? So let's go back to my chart here. Do I have a 39? I do. So I'm on this line here, Okay? Now, here's the problem here. Now notice, let me back up a second. Look at my picture. It's shaded to the right. What is the normal distribution?
Our
Yeah, ours
table has
goes
30 and
30.
40.
Oh, it does?
Yeah, it goes straight from 30 to 40.
Oh, that's lame. I got a better table than the book. Okay? We'll do that in a minute. Okay? Let's use my table since it's better anyway. I can't believe I have a better table than the book, but I do. Okay, so the normal distribution is shaded to the left. The t-distribution is shaded to the right. Do you see that? Okay. Now, what was my t-score that I got? I got negative 1.74, right?
Yeah.
Okay, so here's the problem with the chart. Okay, we're on 39 degrees of freedom. Now your book would go 30 to 40, so you just round up to the nearest number. But since I've got this, I'm going to go 39 degrees of freedom. Okay. Now I've got a negative number. There are no negative numbers. The t-distribution, just like the z-distribution, is symmetric. So for this, I'm going to ignore the negative for now, because, here, let me explain this again. Well, that's all right. I'm going to ignore the negative. Where does 1.74 fit on this line? It's in between those two numbers there, right? Which means it's in between these two numbers here. Okay? So your p-value is in between 0.025 and 0.05. Okay? So if you're using the chart, 0.025 is less than p-value, which is less than 0.05. Okay? So if you're using the chart, you cannot get an exact p-value. It's impossible. Okay? All you can say is your p-value is between 0.025 and 0.05. However, we're using Excel today, right? Okay? So there are some different commands. Here's the commands I want you to use. Equals t.dist.
Oh.
How about that? Okay, now you've got three choices here. What do you think 2t stands for?
Two-tailed.
Two-tailed. What do you think RT stands for?
Right tail.
Right-tailed. Which tail are we using?
No.
Oh, you guys didn't draw your picture again, did you? How come you guys aren't drawing
Why
pictures?
is there no LT on there? You just got to figure it out?
Well, it's going to be the left tail, okay? The T-dist with nothing on it is your left tail, okay? Now, here's what you need to do. I'll finish this, but you really should have drawn your picture. How do we know this is a left tail test? Because it's negative. Well, not necessarily because it's negative. Usually that's the case, but it's because of the alternative hypothesis is less than. It's a left-tailed test, okay? We'll draw our picture in just a moment. Now, what do you think I put in for the x? Your t-score. They should have put a t there, right? Not x. How many degrees of freedom? 39 degrees of freedom. Now, it's asking for the cumulative distribution function. Do you guys even remember what that is?
The what?
The cumulative distribution function. Way back from the second week of class.
Was CUM? No.
No, it's COM, right? Oh, no.
Okay, here's what I'm going to say. You should remember that, and I'm scared that you didn't. But always put true here.
Oh.
Always, always. Okay? We'll talk about that in a minute. So the computer gives me a much more specific value. I got 0.044, which is between 0.025 and 0.05. Okay? Now, let me just mention some other thing. If my alternate hypothesis were mu does not equal 18.1, okay, that would be a two-tailed test, right? Now, here's a little tricky thing about the two-tailed test, okay? T.dist, two-tailed, you'll still stick in this. Your degrees of freedom are still 39. It doesn't ask you to use the cumulative because it knows you're going to need it. And watch what happens here. It didn't work.
False.
Nope. It always expects a positive value. So if your value is negative, just add a negative here to make it positive, and then it will work. Now, you could also take your p-value you got in the first one, and you can multiply it by 2, and you'll get the same value. Okay? So when that comes up on the test, you'll be like, why is it doing this? And now you know it's been recorded. It's on YouTube. Can't watch the video during the test, though.
What?
Only if you want to fail. They watch you like a hawk. Okay? All right. So anyway, I just wanted to bring that up. Now, let's go back here for a second, okay? It's not a two-tailed test, but so let's go back here. Now, let's draw our picture. What's the picture we should have drawn?
Should I draw?
Mm-hmm.
No, distribution.
Nope, not a normal distribution. A t-distribution, which looks exactly like the normal distribution, no? Okay? What is the mean of the standard t-distribution? The standard t-distribution. It's a 0, right?
Oh, standard.
But that does correspond to a value of 18.1, right? Okay? What t-score did I get? I got negative 1.74. You can think of that in terms of standard deviations. It's not exactly the same, but it's close enough. Okay? Do I want to shade the area to the left or to the right? To the left, okay? So this is how you know it's a left-tailed test. Okay? Does that make sense?
Yep.
Okay? Now, in real life, most people do two-tailed tests, but you can do a one or a two-tailed test, okay? If it was a two-tailed test, what would the picture look like? I'd also use the 1.74 positive, and I would shade the area to the right.
No.
Yeah, or so you can take this area, which is 0.044. Over here, you would double it, it would become 0.088. Okay? All right. So, who wants extra credit on the quiz Monday? Who's going to draw your picture?
I'm gonna draw a couple of
Draw a couple of them.
them. Yeah. Do
Go.
you get an extra for each one? Can we just make it like more defined each time?
Yeah.
I'll draw a histogram.
No, it doesn't work that way. All right, let's go back to our test here. And by the way, those commands are on your formula sheet. But when you're on the computer test, you'll be using the chart or the Excel command.
So,
Excel command. But it is on your sheet, tdist, t.dis.right tail, t.dis.two tail. Okay? Step number 6 is,
The p-value.
no, that was 5. We just did that.
Reject or no?
Reject or not. And in this case, Sandra, what do we do? Are you sure?
Oh, wait, but we have an alpha.
We have an alpha.
Alpha is 0.1, and our mu is 0.1.
Are you sure?
Oh, wait, no, we do.
reject.
We reject.
I mean, huh? Which one is it?
It's reject.
Are you sure?
Yes.
Yes, okay, glad. I'm glad. Finally got her to be sure. Okay, and so, Philip,
Null hypothesis.
what's the last step?
Put it in English.
Thanks, Philip.
Oh, sorry.
Oh, sorry.
The last step is what?
Last step is to,
Right, the conclusion, right?
yeah.
And the conclusion is,
There's,
is not. Oh,
There is not. Is that what you said?
yeah.
Did we not reject?
Oh, we reject it.
We reject. So there is
There is a reject.
evidence
Evidence.
that what are we measuring? What's the experiment about? Do you want to phone your friend Dalton?
There's evidence that
Retired smokers smoke less. Who agrees with that?
Am I wrong if I'm agreeing with it?
Who does not agree with that? You did not raise your hand, Philip.
I just don't know, that's why.
Okay, that's correct. Good job, Dalton. Okay? You want to do another one? We've only got 6 minutes left, so we're going to have to hustle. Okay? Let's do one more, okay? This one we're going to have to really hustle.
Repetition is key.
Okay?
Hey, can you share this one afterwards, please?
I can. Did you like the last one I shared?
Yes, thank you.
The Wireless Association says the mean cell phone bill is $50.64.
Is that a question from the book? Just wondering.
I don't think these are in the book.
Okay.
A market researcher believes the bill is different, but unsure if higher or lower. He collects 12 cell phone bills and gets following results. Use alpha equal 0.05. Now, what do you think about 12?
Too small.
Kind of small, but we're going to do it anyway. So we're going to do it because we're going to assume it's normally distributed. Okay? All right, so here is the data. It's 94.25, 70.07, 55, 38.94, 115.59, 76.05, 79.15, 77.56, 27.29, 56.78, 37.01, and 52.48. Okay? First step is
Get the.
find the numbers.
Oh, yeah.
Okay, what numbers do we need?
Calculate the X bar from that.
We're gonna have to find our own X bar, aren't we? Okay, let's go through. It says the mean cell phone bill is $50.64. What'd you say?
The mu equals 50.64.
Mu equals 50.64. Market researcher believes it's different. He collects 12 cell phone bills. Now, by the way, sometimes I miss one. And so check and make sure that's really 12. It is. Do you see right there? It's 12. So my N still is 12, okay? On the test, sometimes I'll tell you it's different, and then I leave off a data or I add one or something. So make sure that it matches, okay? I don't do it on purpose, I promise. Okay?
So
N is 12, alpha is 0.05. What else do I need to know?
X bar.
I need to know X bar.
Just by doing equals average.
Equals average. And
Standard deviation.
standard deviation. Do I know the population?
Yes.
What is it?
Wait, no. Just do ST10.
I can do STDev, and STDev is the sample, right? So it's not a population. So don't be using population. Is this every person that owns a cell phone in America? No. Okay. STDev of this. And you guys know how to do this on your calculator, or you'll find out this weekend, right?
Yeah.
when I put it on the quiz Monday, you can find this without doing that big nasty formula. Okay? Step number 2.
Is it numerical?
It's quantitative, right? We're going to hurry. Step number 3,
We have to do the null hypothesis.
the
So
null is
mu equals 50.64.
50.64. The alternative is
Mu does not equal.
mu does not equal 50.64. So it's going to be a two-tailed test, right? Okay. We don't know if it's higher or lower. Does it look higher or lower? It looks higher, but we didn't know that until we figured out the mu ourselves, right? Or the X bar ourselves, right? Okay. So don't use this and say, oh, it should be one-tailed. No, we didn't know which way it was going. Okay. Step number 4. It's going to be a t-test, right? T equals X bar minus mu S over the square root of n. Okay, we got to hurry here. X bar is $65 and a penny minus 50.64. Standard deviation is $25.50 divided by square root of 12. Oh, by the way, I should have mentioned this. What's the other number I'm going to need since this is a t-test? Degrees of freedom is 11. Okay. Step number 5. Find p-value. This is a 1 or a two-tailed test. T.dist. Two-tailed. Luckily, oh, I forgot to. Sorry, I got to find my t-score. I was getting so excited. I forgot to finish it. Okay, my t-score, that's my t-score.
Yes, it's positive.
It's positive, so you don't have to change it. T.dist, two-tailed, pick that number with 11 degrees of freedom. Now, we also should do this with the chart, 0.07. What does the chart say? The chart is going to be 11 degrees of freedom. Whoops. 11 degrees of freedom, so we're on this line here. I got a value of 1.955, right? This value here. That's my t-score. T-score is 1.955. Where does 1.955 fit on that line?
Between 0.05 between point.
Yeah, it's between these two numbers here, right? Here, I'll highlight those, which means it's between those two numbers here.
You'll say.
Okay. Oh, this was a good one. I'm glad we did this one. Okay, so my p-value is in between what? So it says my p-value is between 0.025 and p-value less than 0.05. Okay. Now, what do you notice there? Is 07 between those values? No, why not? Because that's a one-tailed test I just did on the chart. So in order to do a two-tailed test, what do I got to do? I get to double both of those. So the real p-value is between 0.05 less than p-value less than 0.10. Now you can see that 0.07 is in between those two values. Now that was tricky. To quote Run DMC.
Sorry, I'm like too old, so I know that song.
All right. Okay. That one was really tricky, wasn't it? Especially with the chart. Okay. So step number 6 is what, Jordan? Reject. And I'm going to let you do 7 as well. No, is that reject?
No, I meant reject or not reject. That's what I meant, like this way.
Do not reject.
I just meant like if you're asking for the extra step, not the.
We only said half of it.
Oh, sorry.
So the conclusion is there is not enough evidence that the mean cell phone bill is different. Okay? Now, let me ask you a question. If my alpha was 0.05, excuse me, if my alpha was 0.10, would there be enough evidence? Yes, there would be if my alpha was 0.10. And I probably should have used 0.10 with such a small sample size, right? Okay? But I didn't. If I rejected the null, okay, so let's pretend, so if alpha, let's pretend that alpha equals 0.10, that means we would reject the null, right? And in this case, there is evidence that what? Cell phone cost has increased. Don't just say it's different, right? $65 is more than $50. It's gone up. Okay? You can tell that on the two-tailed test. Okay? All right, what's your quiz on Monday?
Chapter 20.
The T-score.
There could be some Z tests in there, so don't forget the Z.
And his homework due 20.
Homework is due on the 20th, and I'll try to publish it today.
Okay, yeah.
Homework about chapter 20 is due on the 29th.
Whatever that day is. Yeah. Okay?
Oh my goodness. 2 more weeks.
2 more weeks.
2 more weeks until a 10-day break and back in class.
Yeah, that's right.